Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll help get you started with the poster preparation for the research questions, data resources, and analyses. In particular, in this part, we're going to focus on the analyses, and I'll make separate videos for the other two parts. Okay, so we're basically preparing the poster in the bottom of your project file. We want to work out all of the content of your poster before we think about the format of your poster. So if we open up the outline file and go to the bottom of the table of contents, go down to the poster, this is class 24. That's what we're working on. And there's also class 25. Both of them says see items under class 26. Okay? In this section, we're going to complete items 2, 3, 4, and 5. And then for the next class, we'll complete items 1, 6, 7, and 8. So what are 2, 3, 4, and 5? So we'll scroll down to the poster preparation. Here's part 1. We're going to skip that. It says class 25. We are focused on class 24. So we've got research questions, methods, the results from your first research question. It can be, basically we're going to go up and find two analyses that we liked from the previous classes and bring those into the poster. So this is your first research question. It could be an ANOVA, a contingency table, simple linear regression, or logistic regression. And we've got a second research question. All right, so I'm going to focus on basically an ANOVA and a contingency table, I believe. And I recommend you do a full ANOVA. I think my example has a two-factor ANOVA, which is like a two-sample t-test. All right, let's start with the analyses. So I'm going to we'll postpone that for a second. Here's my cumulative project file. Now, you know from experience that in RStudio, when you render your file, it takes a long time to run because each time it runs, it is looking at each code chunk, interpreting the code chunk, evaluating it, producing the plots. That is what takes them most time, over and over again. What I want to show you is a way to temporarily make all of that happen very quickly. So near the bottom of the YAML, this header portion of the file, there is a line that says cache. And we're going to change that to true. Now what caching does is it saves the results of the computations in all the code chunks so that it will save all the results the next time I run this. In fact, I'll start running it now because it's going to take a little while. And as it runs each chunk, it saves the results. When it gets to the bottom of the rendering, it produces the HTML output. Next time we click render, however, it's not going to recompute everything. It's going to check to see if each code chunk has changed. If something in it has changed, it will recompute that code chunk. But if it has not changed, then it will just say, I know what the results are. And it goes and pulls the results that have already been computed, thereby not recomputing all the results. All right, let me go over to my project file. So this is what I ran this earlier. And this will be updated once my RStudio finishes. And we're going to go down to our poster section, okay? And I have the same template as the outline. So I've decided to start right where you guys are starting. We want to pull in two analyses, one in the first research question area and one into the second research question area. Okay, so now I just need to remember what the two analyses are that I want to pull in. So let me search for Somewhere up here I have an analysis that I like. So you'll take some time and you'll scroll through your analyses and find something that you did that you like. Where do I want to go? Statistical analyses. It's going to be under the stat methods section. All right, let me look at my two-sample test. Okay, yes, I think this is the one that I want to do. All right. So my analysis is under my class 15. I recommend, however, that you don't do a two-sample t-test. Try to find an ANOVA. Okay, so then I'm going to go over here to my project file, and I'm going to search for class 15. Okay, and I'm going to go down and grab the analysis that I did. So I'm going to put the cursor at the top of the analysis, and then I'm going to scroll down and press Shift and click, and that's going to block everything that I want. Okay, that's it. I'm going to copy that. I'm going to scroll down near the bottom. Okay, results of your first research question. I'm going to paste it in there. Okay, pretty close. We have one comment. I think I'm just going to rerun. It looks like it finished rendering. Let's see what this error is. Can I open the connection? It had trouble writing the markdown file. Not sure why. I'll just click render again. And we'll see it should... Cannot find function. All right, I wonder if this happens with rendering for the QMD file. Okay, interesting. I hope I don't have to debug an issue on a video. All right, I have a guess as to what this is. So when it, unfortunately, okay, QMD files in Quarto work differently than R markdowns previously. One difference might be that cache equals false. Let's see if this works. So one issue when you click render is it opens a new environment. Yeah, it's working now. It opens a new environment. If chunks are cached, it will go find the result and keep going. However, when you load packages, a package is not a result. It's a way of setting up your environment with the appropriate functions that you need. Therefore, you can't cache these options with the library chunks. So let's see, did it finish? It did. Okay. All right. So if you turn on caching in your YAML, then you also have to set cache equals false in your first code chunk where you run your library commands. Another way to do that is hash pipe cache colon lowercase false. Okay, that will do the same thing. All right, let's click render again. So now we shouldn't be afraid of rendering. When you click render, it loads these libraries, and then it scrolls through all of the chunks immediately, and we're done. We love that. All right, so let's go look at our output project file. I'm going to scroll near the bottom and page up. Okay, so here's the poster. In class 26, we're doing our poster prep. Here's the results of our first research question, and this is where we pasted our results in here. Okay, so we've got the results of one of our two analyses. I'm going to just keep it the way it is for a moment, and let's go get results for our second research question. This one, I think I want to go get one for my two-sample contingency table, or 2A contingency table. Okay, so let's go into my table of contents, statistical methods. I'm looking for 2A categorical analysis. Yes, let me do this analysis here. All right, so I'm going to scroll up. This is from class 21. So I'm going to come back over here, choose class 21. All right. And all right, that's part of the original question. I'm trying to find pieces that apply to me. Okay, specify the hypothesis. All right, so I'm going to start there, go down through the end of the interpretation. The next section is linear regression, which this is not. I'm going to copy this, and then I'm going to scroll down near the bottom, find the place for the second research question, and paste it in there. Okay, so now I can render it. Excuse me. Watch how fast this is going to be. Now I added a few new code chunks. So here at the end, it pauses while it runs those new code chunks associated with the code I just pasted in, but then it's done. All right. So if we open this back up, we've got, I'll scroll down to the poster. All right, where are we? Results of your second research question. And then here's a bunch of that stuff. Good. So I've copied and pasted it in. Now we're going to spend a little bit of time and make it look nice. Okay? And I'm going to do this pretty quickly in this video, but you should take as long as you think you need to basically make, select the items that you want to include in your poster and really be selective, right? Don't include a bunch of extra stuff. All right, so let me scroll up to the first one. All right, here's the first research question. All right. And what I want you to do, plot and describe the data as well as the statistical model. That means don't plot the statistical model, describe the data and describe the statistical model. This can often be done in a single plot. And we're choosing one of these. This first situation is basically an ANOVA. Okay, so I want to have a mean with confidence intervals, and I want to have some information that shows that whether there's differences between the means or not. And I want to state the conclusion of the hypothesis test and interpret it in terms of the research question. We're going to write the research questions next. All right, so I'm going to delete all of this stuff here. That's guidance. All right, so I'm going to remove all the words that we don't need. So our main question is the population mean total cigarettes smoked greater for people with depression than for those without depression? Question mark, because it's now a question. Okay, and I might, for notation, I might say that is, comma, okay, null hypothesis versus alternative hypothesis. Perfect. So that's a nice introduction of stating what we're studying. Then we perform the t-test. We might not output the result of the t-test, okay, but we do need the object because we're going to have test statistics and p-values and things like that. Let's go take a look at the project file. and see where we're at. So here's the results of the first research question. I deleted all this text. I improved the question that's going to be asked. Then we have to think about what output we want. Now, we don't want this code showing up in the output of our poster. So in our code chunk, we're going to say hash pipe, which is a code chunk option. Oh, come on. Hash pipe, echo, colon, false. That means it's not going to echo or output a copy of the text from the code in the output. All right, so let's run a render here and see how that changes the results. All right, so that will finish in a second. We'll go look at it. All right, so here's research question. Here's our question. Is the population mean, etc.? And then we don't see the t-test code right here anymore because we did echo equals false. But we do have the output. Okay, what else? What other information do we need? We probably should plot the data first and then test the model assumptions and then show the conclusions. So we've got a test statistic here, we've got a p-value here, we've got a conclusion. So let's hold those for a moment. We don't need the significance level of 0.05. But let's put a plot in here. If we go back over to our output and we scroll down a bit, we've got this plot here, a box plot with the points. We also have this in terms of a histogram. Which one do we like better? I'll probably just go with the histogram. I think they're both fine. But I'll use the histogram plot since we've got a choice. All right, this one is the box plot code. I'm going to delete that. This one is the histogram, and we're going to keep that. So I'm going to cut that, move it up, and paste it here. We've got a width of 6 and a height of 4. That seems fine. Let's also do hash pipe echo colon false so that we don't output the code, but we will output the plot. All right. What else do we need? Some model assumptions. Okay, so let's grab, I'll show you what this looks like over here. So I do this 2-sample bootstrap, and these are the results, and it shows that the sampling distribution is very close to normal. Now, in an actual poster, I probably wouldn't include this, but for the sake of our class, this might be a good thing to include. So I'm going to include this plot as well to show that model assumptions have been met. So I'll copy this and I'll move it up after this plot. Good. All right, and then this is probably a good time to render it because we've changed a few things. Let's make sure that we have echo equals false for each of our code chunks here. We can also change the size of the plots later on. Oh, is it still running? There, just finished. All right, so I'll scroll up to the top of this section. Okay, here's the results of first research question. We've got the question, we've got the plot here. I need to take this away, and then we also have the model assumptions. Now we could probably put these two plots side by side, right? We learned how to do that earlier in the semester. Now is a good time to revisit that concept. Yeah, and then we've got the conclusions here at the end. All right, so we're almost done. Let's go remember how to put two plots side by side. I think I've got, excuse me. I think I have a section in figure arrangement, okay, class 6. And I think I even included some of the text for this, yes, right in the output. So we want maybe, well, okay, if we had two ggplot objects, we could put them side by side. The problem with, in this particular case, is that I have one ggplot object, which is this, but the other one is a base graphic from R. And probably can't make them both go into the same plot because they're different structures. So instead, oops, that didn't work. Class 6. Instead, we need another way to put them side by side. And I think that's this method here, I think. Okay, so what I can do is I can search for fig subcat in my code, and it will bring me to where we're doing all this figure arrangement. All right, let's find an example. All right, so we make two plots, and the arrangement is when you've got two ggplots. This is going to be the best option for most of you. So if you've got two ggplots, you're putting them side by side, use this method. In my case, I've got one ggplot and one base plot, and that is going to use all this header stuff where I've got a figure caption, and then I've got a subcaption, and then I've got a layout for columns or rows. So I'm going to grab all this header stuff, the chunk options, and I'm going to bring that down to where I'm making a table. Am I close? All right, first research question. So I've got my first plot and then my second plot. All of these, the plot, these plots are all going to come together into a single code chunk. So I've got echo equals false. I'm sorry, this is hard to read. Let me change my appearance to something that's more, what's the default? I forget. This white one would probably be pretty easy. Okay, we can read this a little better. We have labels. Okay, so this is going to be, let's call this fig poster analysis 1. All right, figure caption. I'm not sure yet, but we'll come up with, so figure caption here. I'll improve that in a moment. The figure subcaption, I think this is going to be, so this is the first plot on the left. So I'll just say histograms. I'll improve that in a moment. And then this second caption will be something about model assumptions. Okay. The layout, one column is not what I want to do this time. I want to do a layout. Puts 2 on one row with 10% width space in between. Okay, that looks pretty good. And we probably don't want these to be equally wide. Let's make the one on the left about 2/3 and the one on the right like that, and 5% in the middle will probably be plenty. Okay, the figure width probably overall is maybe about 8 inches, and then the height of 4 is probably good. Okay, so I'm making some guesses. So then the code chunk has to produce 2 plots. The first plot is here, and the second plot's down there. So I'm going to delete this, the end and beginning code chunk designators, the triple ticks, to put all of it into one plot. Okay, and that's the second plot. We've made a bunch of changes. Let's click render and see that this works. Now it thinks I've got an error here, but I don't think we do. All right, I'll open up the output and we'll jump to the bottom, page up. Okay. Results for your first research question. There's the text from above. We have a warning about removing missing values. We probably want to have that not echo out. I'll show you how to fix that. There's our first plot with the label A, second plot B, and here's the figure caption. That's pretty good. I think the only thing really to change is making this taller. And I'm not exactly sure how to do that. This figure width and height applies to both of them and applies to both plots, and then they end up getting scaled. One is 65%, the other is 30%. So what if we make this closer to, say, 49% minus 2, 49%? We'll just make them equal. Okay, so we'll render that again. And then we just need to come up with some summary, right? We want to talk about the model assumptions in panel B, and then we want to draw the conclusion related to panel A. Okay, just finished. Okay, there's half and half. The text now is probably a little bit too small. That's because the size of the plot is ultimately too big. So if we change this width to, say, be 5 inches, so we're making a smaller sized plot. If you put a smaller plot in the same space, the text will be bigger. So we'll see that in a second. Okay, so we're pretty close. So the last part is doing some cross-references. So let's recall class 06 figure arrangement. We referred to some of our plots. Let's see. Okay, here's the labeled plot here, and then below I've got the interpretation, and I refer to the plots with an @ sign, and then -1 and -2 for the subplots inside. All right, so I'm just going to copy that as a way to remember. I'll scroll down to where we're working. Okay. Our figure plot. Oh, you know what? Let's not call this -1. Maybe underscore the word 1 for analysis 1. Okay. Now we've got a -1 and a -2. Okay, so we can say in figure in figure 2, comma, the bootstrap sampling distribution of the difference in means is close to normal. So the model assumptions are met. We can rely on the decision. We can rely on the results, I'll just say. Okay. Then we can state what the results are. Okay. Okay, so what parts of this do we need? Let's see, if we scroll up for a second, is the population mean total cigarettes smoked greater for people with depression than without. Our one-sided two-sample t-test resulted in a test statistic let's see, was it large? Yes, it was very far from 0, 17 standard errors away. We usually look for about 2 to be large in a large test statistic, and we show the value. I'll put it in parentheses. Thus, based on our p-value, less than 0.05, we reject H0 in favor of HA, concluding that the population mean cigarette smoked is greater for people with depression than those without depression. Okay, I didn't refer to the figure, so I also want to say something about the figure. Okay, so let's write one sentence to interpret the figure. I'll put that above this one. In figure 1, the distribution, each distribution of number of cigarettes smoked per month, I believe. Each distribution is right skewed with the mean of those with depression being slightly greater than those without. Okay. And if we really wanted to, we could probably annotate somewhere what those means are. So one place we could put that as parenthetically right here. Okay, so that's sort of an extra thing to add if we wanted to do that. It would be pretty easy, of course. In fact, in this t-test result, I believe, oh, of course I don't have it here, but I think the t-test result has an object in it with the means. So let me run all the code from the top. Oh, that'll take a moment. Okay, in the meantime, let's go figure this out. So this warning is showing up. And that happens when this code chunk runs. So there are some other options. I think there's like warning. Yes, warning : false. So even if there's a warning, it won't print it out. All right, so I'm going to render this as well. Rendering, right, goes into this background jobs. It's separate from what's running in the console. So those two things are happening at the same time. Okay, it's creating the output. All right, now it's jump back to the console where it's running all the data. Let's go look at our updated cumulative project file. I'm going to refresh the window, but we still have a warning here. So that's not where the warning came from. Let's see if it's in this plot. It might be in this when we do the plot. So let's do warning false in there. We'll render that. Okay, I'm not going to do the full formatting of the second analysis, but I wanted to show you some of the workflow of getting this working. Okay, the background job finished. Aha, we've done away with that warning message. Excellent. So now our result starts with the research question. Effectively, we state it in notation. That could be part of the same sentence, or we could bullet point this. It's a style choice up to you. We've got a plot on both sides. We got in figures 3A, perfect. Now in your actual poster, this will be labeled as figure 1A and 1B. Okay, but each distribution of okay, I'll improve my writing. Each distribution of the number of cigarettes smoked per month is right skewed, with the mean of those with depression being slightly greater than those without depression. And I'm going to put those means in these parentheses. Figure 3b, the bootstrap sampling distribution of the difference in means is close to normal, so that, and that's really the bottom plot. Let me go annotate that. Okay, the distribution of the number of cigarettes, and the bootstrap sampling distribution of the difference in means is close to normal. So that's the bottom panel of the plot. So the model assumptions are met, and we can rely on the results. Great. Our one-sided two-sample t-test resulted in a large test statistic. Thus, based on our p-value being incredibly less than 0.05, we reject H0 in favor of the alternative, concluding that the population mean smoked is greater for people with depression than those without depression. And we don't really need the variable names in here anymore. That was sort of helpful in our development, but once we're ready to present this, we don't really care about telling our audience what we called our variable names. So I'm going to tidy that up. Take away those variable names. In the research question as well. Okay. Last part I want to do here is I want to see if we can annotate the means. So we've got this T summary, and there are two means here. Okay, the no depression group and the yes depression group. So this object, $, might be under estimate. That's aha, $, no. How about bracket 1? The first one, okay, and the second one. Cool, we can get to it with that number. The no group is number 1, the yes group is number 2. So when we come down to the sentence that we're writing about the means, those slightly greater, let's see, those with depression is slightly greater, so this is the yes group, that's number 2, and then the next one will be number 1. So let's write our R code here. We've got R code, we've got this number that we're evaluating, and as I typically do, let's also truncate the number of significant digits to be 3. All right, to see that this works, I'm going to highlight just the code and press Control-Enter, and it is printing it down here. Now notice there's sort of two things that's being printed. There's this label, and then there's also the number, 253. That will probably work. It will probably just print the number, but if we have an issue with this, I'll show you how to fix that. All right, so I'm going to copy this and paste it here for those without depression. That is going to be the first number, and let's render that. Okay, is there anything else that we need to get rid of? There's this thing about, because we rejected the null, we could have made a type 1 error. Let's not worry about those type 1 and 2 errors. This looks like where we actually calculated means, so we could have used this estimate for means as well. Let's go look at our output. Slightly greater, 253, than those without depression, 173. Cool. So we've got the means in there. Awesome. We don't need this, so we'll get rid of that. And we might be done. Let's render it again. And if we're happy with what we did, then I'll stop the video and we'll move on to the next part. Oh, right. There's a couple more pieces, things to do. There's always a little bit more to do. But, all right, result for your first research question. We've got the question. We've got the plots. We interpret the plots with these bullet points, and we're done. The only thing left to improve are titles for our plot. Okay? Oh, I'm with you. You can always turn off the video, right? You probably already did. But our figure caption will be sort of analysis 1, 2. It's sort of 2 sample t-tests, but that's not really the title of the plot. The title of the plot is that I sort of want to label it with the actual result. So that's not letting me copy very well. Let's go to the conclusion. Concluding that the population mean total cigarettes. Okay. So, figure caption. Total cigarettes smoked is greater for people with depression. Period. That's the overall conclusion. Okay, so this is the plot on the left. Model assumptions, sampling distribution of the mean is normal. Okay, and then over here, I'll say just samples are right skewed. Okay, something like that. Cool. All right, that's it for now. Do that for both of your research or each of your 2 analyses, and then I'll see you back here in the next video to talk about the what are we talking about? We're talking about research questions and data sources. All right.